All right, welcome to I believe this is the first USC Center for AI and Society virtual seminar for our calendar year 2022. And it is my pleasure to introduce today Dr. Patrick Fowler, who will be speaking with us. And let me just pull up my cheat sheet. Okay, so let me read a brief biography of Dr. Fowler before we let him take it away. So Dr. Fowler's research centers on homelessness prevention and the negative consequences of homelessness for youth, families, and communities. His recent research focuses on homelessness among youth aging out of foster care and child maltreatment prevention among families experiencing homelessness. Using linked administrative data, Dr. Fowler designs and tests big data applications to improve the fairness and efficacy of homelessness services delivery. He employs a complex systems approach to create developmentally appropriate and culturally tailored responses to homelessness. And for those of you who know some of us here at CAIS, especially myself and Dr. Phoebe Vianos, I'm sure you can immediately understand our attraction to Dr. Fowler's work. And so without further ado, Patrick, I'll let you take it away, and hopefully you have the ability to share your screen.
Hold on a second. Yes. All right. Oops. Okay. Thank you, Eric, and thank you, everyone. I am super excited to be here. We're going to be presenting some work that we haven't presented before, and I think it's really this is the perfect group to talk about this with. So we're looking at what happens when we provide algorithmic information in decision-making contexts that face a lot of public services. So one way to think about this is, oh, yeah, these are washed out. One way to think about this is imagine you're on the front lines. So you work at a homeless shelter. Your program has 200 beds for adults and families. There's also a small program that has some small number of apartments, and your job is to figure out who gets the apartments. So on the left is a shelter in St. Louis, typical shelter, bunk beds, congregate setting. You can sleep there for a couple nights, up to 30 days, or you can get an apartment that you can keep for 2 years, and it comes with supportive services. Your job is to sort it out. Now let's imagine that you are at your job and there's a new policy that says you get a score that predicts each household that comes into your shelter whether they're going to do well in the apartment. How does that change the way you make decisions? That's the main question that we're tackling. And the way that we're framing this is, this is a scarce resource context. Scarce resources are the way the world works in social service delivery. We kind of inherently don't have enough of the supply to meet demand. And traditionally, social workers are trained to collect data and do assessments. They're trained to refer to policies and best practices on who to give what to whom. And they use clinical judgment. They're using their experiences, they're using what has worked in the past, what didn't work, and then sometimes they're just taking bribes. So that also happens, but probably less frequently. And the folks here have been really showing us how AI can address this scarce resource allocation problem. So we can think about using risk predictions. So on that shelter worker, I get a score of how risky this person's gonna be if we don't give them services. And I can use that to inform my decision. If they're at low risk, maybe I don't need to prioritize them for that special apartment. We can also use AI to look at heterogeneous effects in treatment. We can think about not just risk, but also probability of response to an intervention. And so we can think, this person is way more likely to do really well in the shelter versus really well in the transitional housing. And we get these micro level predictions on this. We can start personalizing and prescribing interventions. AI can help us think about optimization. So we can think about how we want to allocate resources that maximize some function, and it could be maximizes efficiency, could be maximizes efficiency with conditional constraints to ensure some definition of equity. Research is moving into how do we define fair? How do we define equity? Thinking about, if we were designing fair systems, how should they look in terms of the allocations to households? And we can monitor those allocations to calibrate our decision-making systems. And we think about, game theory. How can we incentivize or minimize disincentives for people to use services? And we can think about carefully designing our services where we're maximizing folks getting their preferred service, we're minimizing cheating. And we see this. So now that Watson's on it, we can expect big changes in the future. And it's still, it's addressing this fundamental question of who gets what, when, and how, which has been used to define the field of economics. It's been used to define the field of politics and political philosophy. And from a social work perspective, it's just kind of what we do. We have to make these terrible, hard decisions, and AI is presenting lots of new opportunities. So it's also important to consider how we design the use of these new tools. And an approach that we've been exposing, subjecting our doctoral students, we make them read this book called Local Justice. It's from 1991, maybe, by John Elster, who's a political philosopher, who sets up a really good framework for addressing a certain kind of allocation problem. It's local justice, not global justice, in that these are problems where we have to allocate a scarce resource that is typically allocated by an institution that has some agency on implementing a strategy for allocation. It's not just a global policy like utilitarianism or libertarianism, but rather it's the day-to-day interactions that social workers are doing. I am a social worker. I am deciding who's going to get that apartment. I have my conceptualizations of what I think is fair, and I work based on that conceptualization to implement my allocation scheme. Elster talks about all sorts of markets that we see this. So, who gets a kidney, who does the dishes? So how do we allocate the responsibility of household chores fairly? Who gets drafted, who gets public schools? These problems we're trying to maximize the aggregate welfare of individuals. So we have these strategies where we might say, the fairest way to do this is first come, first serve, or the fairest way to do this is to select within a subgroup. So we have this framework, and kind of an interesting implication of this local justice framework is that there's really there's only a handful of ways that we define fair. And it's an overgeneralization, but go with me. The two common ways that we define fair is we think about pre-allocation need and post-allocation outcomes. So when we're thinking about fairness, we might think, well, it's fair to provide the neediest the resource. I've got my few apartments, I'm going to give them to the people who need it the most. Or we contextualize this as around the outcomes. So I've got my apartments, I'm going to give them to the households who are going to benefit the most. Those are two different things. Sometimes they're related, but not necessarily. So we've got these two notions of local justice that we can start, designing a system around, our strategy around. So, for example, we've got data on survival. We could have a needs-based curve, which is just giving the person at most risk the resource, or we could look at the rest of the curve and think about who's going to be most likely to survive after a certain point. Cut. I think I've already said this. So applies directly to our scenario where we're allocating apartments. But the reality is that our systems have multiple allocation goals, and often they are conflicting. So in homeless delivery, we have, on one hand, we have a policy that requires communities to prioritize households, and it requires communities to define who's going to be prioritized for more intensive, scarcer resources, and that is baked into how services are supposed to be delivered. At the same time, the very same HUD policy requires communities to report and measure how much they're preventing homelessness. So as a dashboard, system performance metrics hosted by HUD, they have indicators like what is the rate of reentry after exiting a homeless service within 2 years. And the idea is that communities should be year to year reducing that rate. There should be fewer and fewer people returning every year. And these are two different things. So prioritizing based on some feature like chronically homeless, someone who's been homeless for 2 years, is going to have an impact on your measurement of your rate of reentry. If you're prioritizing the highest vulnerable groups, you're probably going to have a harder time reducing reentry because they're vulnerable groups. And just to point, one of many examples where we have competing interests in terms of allocations. And so what this results in is confusion, where communities are unsure what they're supposed to be doing given inconsistent messages. And then we introduce some AI thing, and they want to punch the computer. Like, oh my God, how am I going to do this? I don't know what to do. So we also know from decades, if not centuries, of cognitive science that humans make decisions in ways that are not always ration based. So So that caseworker who is deciding who's going to get the apartment can be told to maximize or prioritize the most vulnerable, or prioritize the folks who are most likely to benefit. But they're making these day-to-day decisions in a context of competing frames. So Daniel Kahneman and Emus Tversky have, I looked it up today, they have, I think, 435,000 citations to their work, which is incredible. Very, very influential. The basic point is that, as humans, we are lazy. So we like heuristics to make decisions quicker. And we are very vulnerable to framing. So in one of their seminal papers published in Science in 1981, they show how framing influences, how the framing of information influences the choices that we make. So I'm going to read this because I'm not sure if everybody can see this, but this is from that 1981 paper. Imagine that the US is preparing for the outbreak of an unusual Asian disease, which is expected to kill 600 people. 2 alternative programs to combat the disease have been proposed. Assume that the exact scientific estimate of the consequences of the program as follows. If program A is adopted, 200 people will be saved. Program B is adopted, there's a 1/3 probability that 600 people will be saved, and a 2/3 probability that no one will be saved. Which do you choose? And the framing of the questions influence how likely one makes a decision. So when we say a program is going to save people, we are much more likely to choose that one. And we have this systematic way of considering our odds. So what this means is that decision-making is influenced not just by the goals of a system, but also how we present information. And it's how that interacts with individual decision makers' ideas of fairness and their prior experiences. These frames work at multiple decision points. So we can frame outcomes to get predictable responses. If we can elicit risk-taking versus risk aversion behaviors. We can mess with the valence of decisions and get predicted responses. So if we say, would you rather have something that's 75% lean or 25% fat? They're both the same, but we're going to gravitate towards lean, and that's triggering our valence, a reaction to our past experiences. And we can mess with decision making by framing the goals. So if we just frame it as your goal is to accumulate resources or versus avoid loss, those create these predictable shifts in decision making. And so this quote on the right is the last sentence of that 1981 Science article, which I think really just sums it up. Given that we have these frames, we know that they affect our decision making. How we design our decision making systems becomes a fairness question. When we are introducing information into a decision making system, we need to think about what exactly is happening, and we also need to assume that any decision-making system that we have is not just going to be rational. So giving caseworkers predictions on homelessness is not going to necessarily just make them a rational decider. Let's use the predictions to make decisions. And in fact, giving information can induce the opposite of that effect if not done carefully. Okay. So this is really what we're talking about. We are in this space where we're trying to integrate algorithmic derived information, and there's some key questions that we need to ponder. So how is the information being received? Is there framing going on? Are those framings eliciting unintended consequences? Going back to this local justice thing, just to point out that fairness falls into kind of two preconceptualizations. One is the minimize pre-allocation welfare, or neediest first. The other is to make things efficient, maximize the benefits. So the question that we're asking is, what happens when we introduce algorithmic predictions into scarce allocation decision making? And in particularly, what happens when we don't say a goal? So in the context where you're not really sure about what you're supposed to be doing, what happens? What's the nudge that happens when we introduce algorithmic information? This work is building off of stuff that my colleagues Samai Das and Amanda Kubi have been working on for the past years, where we're generating counterfactual predictions of the likelihood that a homeless person will come back into the homeless system within 2 years. So we have developed an approach to use administrative data to predict reentry rates. And so we know the factual reentry of a household, and then we can play with our counterfactuals to consider what would have happened if they got a different service. And with this information, we're asking kind of two big questions. These are sketchy hypotheses, but basically we think, based on the local justice literature, that folks will make decisions based on two criteria. One will be they're going to look at vulnerability. They're going to prioritize services for the most vulnerable. The other one is they're going to look at efficiency. They're going to prioritize services for the best outcomes. And we think that presenting algorithmic predictions is going to increase the outcome-oriented decision-making. We think just in the nature of the information, what we're presenting is the probability of returning to homelessness. We think that's going to nudge folks towards thinking about the outcomes. And then this one is, I think makes sense. I'm not positive that it makes sense, but we think that not only will presentation of algorithmic predictions will increase outcome-oriented decision-making, we also think it's going to have the opposite effect for those folks who are more vulnerability-oriented. So the idea is that if I really like the idea of prioritizing someone who's vulnerable or needy, and you give me information that nudges me towards thinking about outcomes, I'm going to push back. I'm going to take that information as disconfirmation of my prior. My prior is that fair is giving it to the neediest, and if you're telling me to do something different, I'm going to push back. Okay. So this is the basic frame of the study. So this is a, oops, yeah, sorry. The way that we considered how to get at these hypotheses is that we used an experimental study posted on Amazon Turk, where we had folks play the role of that caseworker. So their job is to make decisions on providing a scarce resource, which is supportive housing, defined as basically it's transitional housing in the data. And we introduce this as, you've got this scarce resource, who do you give it to? We are introducing predictions, again, that's based on prior work, where we have pretty good predictions of reentry given intervention. So our algorithmic predictions, we're pulling from that prior work and we're using them in a series of vignettes. The Turkers are, it's about 550 folks. We required them to be in the US to contextualize this as a US homeless problem. Yeah, so you can see who completed the survey. We have not done this with experts, like actual caseworkers, because we thought that they would be influenced by policies. So they'd be trained in different ways to make decisions. And so instead of trying to tease that apart, we're using these on non-experts. Okay. The experiment, it's an experimental study with 3 tasks. Everybody does all 3 tasks in the same order. So the first task is, we call it the effective training task. This is really sort of unrelated to our primary hypotheses, but I'll explain how it is in a second. This is a task where we are showing folks a series of households. So this is really small and blurry, so I apologize, but basically this is a table of 10 households. These are drawn from the data of and their features. So that first row is number of household members, number of children, head of household gender, head of household age. So for each column, you're seeing a different household. Half of the people in this first task are randomized to see the probabilities of their reentering, of these households reentering using what we frame as past administrative data. So that's the nudge. And the way that we do this is we train them through a series of we just go through and we say, these folks highlighted in red have a high probability of returning to the homeless system if given transitional housing. And then we go to another color. These folks have a low risk of reentering if given transitional housing. And we do that for transitional housing and emergency shelter. So basically what this is doing is introducing algorithmic predictions. Half of them are exposed, half of them are not. Second task is we're asking folks to prioritize who to provide transitional supportive housing. So this is the scarce resource. They are presented again with these vignettes where it's households in columns, features of the households in rows. And in this task, we're randomizing whether or not they receive the last 2 rows of this table. So everyone gets the same 10 pairs of households asked to prioritize for transitional housing. The difference is the folks on the right get the predicted probability of reentry given the intervention. So again, this is the nudge. This is the algorithmic prediction. And then third task is a task where we're asking them to do the same thing, prioritize to the scarce resource of supportive housing. And we are only presenting them with the algorithmic predictions. And we're just binning those as low, medium, high. So they're only seeing the predictions. This randomization is in thirds. 1/3 are told to make vulnerability-oriented decisions. So identify the needy household and give them the resource. 1/3 are trained to or told to make outcome-oriented decisions. Identify the household who's going to benefit more and give transitional housing to that household. And then 1/3 are not told anything. So in this task, we're trying to identify just how people make decisions. Okay. So I hope this makes sense. This is kind of a lot. There's a lot going on here. And I presented the 3 tasks in order. And we are actually looking at the combinations of tasks to answer our research questions. So we'll see how this goes. Okay, so I'm first going to present the results of each of the 3 tasks, and then I'm going to go back and show how they combine to I think show some pretty interesting results. Okay, so effective training task. So this, we endearingly call this the Eugene task. None of us really like this task. We think it's boring. It's basically asking, do humans do better in predicting outcomes when trained? And how do they do compared to an algorithm? So boring result is that when we train folks to try to figure out based on predicted probabilities of reentry into homelessness, we can do it, but they're still way worse than algorithms. Fine. So that's in itself is sort of okay. It fits prior research that shows algorithms can improve decision making, especially when the task is complex and based on lots of features. So homelessness seems to be falling into that category. And remember that we did get to nudge people. We exposed half of the people to algorithmic predictions, and the other half were not exposed. Okay. Second task, the effect of algorithmic predictions task. This one, what we did was we created 2 scores, an outcome-oriented score and a vulnerability score-oriented score. So this is the task where you see 2 households and you're asked to prioritize. And the score basically is, did you pick the outcome-oriented household or did you pick the vulnerability-oriented household? There's 10 pairs, so each of those can add up to 10. So in higher numbers indicate higher outcome orientation or vulnerability orientation. Again, what we find is that when we randomly present algorithmic information, it increases the outcome orientation scores. So showing the numbers nudges people to think about the goal of maximizing outcomes. Okay. Task 3, decision frame elicitation task. So this is the third, where we are only presenting the algorithmic predictions, and we're asking them to assign based on predictions. This one's kind of interesting. So for the 1/3 of groups, the 1/3 of participants who are not given any instructions, we see kind of this clear distinction. There's two types of decisions happening. So this is that outcome orientation scale, vulnerability orientation scale. Basically what you see is that there's a group of folks who score high on outcome orientations, and they score conversely low on vulnerability orientations, and vice versa. So our hypothesis was that there was going to be kind of two types of decision makers, the needy first or outcomes first. And so we see that. Now, this is, so this is where it gets confusing. So I apologize. Okay, so now that was our third task, but we had been nudging folks all along with exposing to algorithmic information or not. So when we look at the third of the folks who were not told how to make decisions, and we look at whether they were received algorithmic information in prior tasks, we see a shift. So training is training in the first task, which is here's how households fare based on past administrative data. And then vignettes are the table of that includes just the household features versus the household features plus the predicted probability of reentry. And you can think about it like there's every nudge is exposing more algorithmic information. And so what we see is that outcome orientation goes up when we nudge, and so just showing the data generated predictions is making people more outcome oriented, and not true for folks who are vulnerable oriented folks. So if you think prioritizing based on need is the right, fair thing to do, and I present more algorithmic information, I am going to do the opposite. If I am a person who really believes in efficiency and you give me algorithmic information, I'm going to make more of those outcome-oriented decisions. So we see this, it is sketchy, but it fits this kind of cognitive psych literature where we use evidence to confirm our prior, and when that evidence conflicts with our prior, we disconfirm it. We treat it as false. So what does this all mean? So we are in this space of designing mechanisms, designing systems where humans are interacting with algorithms in scarce resource contexts. We've got lots of opportunities to improve efficiencies. We've got opportunities to monitor equity, even by just creating definitions of equity and creating policies that articulate what is equitable, that articulate how equity would look when we check the data. These are really, really powerful tools. We also know that from all sorts of algorithmic fairness literature that humans are biased and data are biased. And when we put them together, you have to be very careful about the system you're designing. Well, I think what these results show is that not only do you have to be very careful with the system you're designing, creating the right incentives, you also have to be very careful with the implementation, because in contexts where we are presenting algorithmic information to folks who don't want to listen to it, we're gonna have problems. So all of the significant advances we make in allocating resources efficiently and equitably will get jumbled in the implementation. Okay. This is work that really we've been doing for the last year, and it's been fun. Last couple of years. It's really, if there are questions, one of the papers is under review, but yeah, we hope to get it out into archive soon. And yeah, I do have to acknowledge the folks at WashU who've been just really fun to work on this. It's a team of social workers, computer scientists, my colleague Sanmai Das at George Mason, who's working with economists. So it's just been an interesting collaboration. Okay.
You can hear my applause, if even though you can't hear the room of the other 55
Thank you,
folks.
Eric.
Yes, thank you so much for sharing this. I think we have a question and answer feature here. And so if you are a participant and you would like to ask Dr. Fowler a question, please put it in the question and answer. So it looks like, Patrick, are you able to see this question? I'll read it for those who are somehow unable to this, but what are your assumptions about outcome-oriented decision-making and equity? Isn't outcome-oriented decision-making by definition going to reinscribe whatever systemic racism, sexism, et cetera, already exists in the system? It seems to me that the point of outcome predictions is to identify systemic issues and opportunities for improvement on a system level rather than to make individual level decisions. By the same token, is the goal to achieve outcomes that may be achieved anyway, even without our intervention, or is the goal to achieve outcomes that can be achieved only by our intervention, which seems a very different goal? Softball question for the first one out of the gate for you, Patrick.
Yeah, great question. And I think it's absolutely right. And it seems like the tools that we bring, if only focused on predicting risk, will perpetuate these inequities. And so the data are biased. So I am hopeful for the other tools that we bring. So thinking about optimization. So we can think about creating constraints in novel ways. We see these risk ratios. We can create policies that better handle what we want to happen. And so we can define our metric of fairness and we can calibrate based on that. I also think that these heterogeneous effects or precision policymaking provides a different lens that we haven't had in the past, which is really like what's going to benefit someone the most. So that's a different question. Still very, very important to look at inequities in the data. For example, access to services based on identities is going to be segregated. You're going to see disparities there. And you can see the disparities there. So it provides a starting point where we can think about, what does this data mean? And what could it mean if we allocated resources differently? So yeah, I'm not sure if that addresses the question, or if I missed a part of the question.
No, I think you addressed a lot of this. I mean, it's this high level question about, how do we create fair systems when the data itself may be biased, and then how do you generate predictions about outcomes that may or may not, be dependent upon that. And I think you addressed that really well. I have while folks pull up more questions, I actually have a question / comment about this work. Strikes me as being highly relevant based on some experiences that I've had with community members in the past few weeks. So like you, Phoebe and I are working on the problem of how do we help to create algorithms that can make some predictions about how well people might do in some contexts. And I thought it was really interesting when you presented the work about people having this bias towards their priors, right? So if people are thinking that vulnerability is what should be, the decision making should be about vulnerability, that the additional algorithmic information about efficiency or effectiveness is discarded, if not even people were reducing their direction and going that way. So one of the things that we've been working on is that kind of the balance between fairness, efficiency, and vulnerability as all being a part of the equation. And I've started to encounter a priors bias around fairness that I was not anticipating, which is that, and it relates a little bit to the last question that was here, which is that, how do you work with communities in a sense who believe that data is inherently biased and that it may not be possible to create an algorithmic system that is anything other than something which perpetuates bias? And how do you, and in a sense, framing, this is an issue about framing, and it's also an issue about what people's beliefs are going into the framing. And so I don't know that I have a very concrete question per se, except the general experience of people having priors about the fairness of these systems that impacts the way that they perceive algorithms, and kind of wondering if you've had similar experiences with community collaborators and how you've been kind of thinking about creating good frames for these conversations that are helpful.
Yeah. No, recently, my most recent example is a failure. So we're proposing to do some evaluation of the emergency rental assistance in St. Louis. And we proposed this idea of identifying the bad acting landlords through an algorithmic system and building out some capacities to deploy city resources to intervene on bad acting landlords. And they said, no, that is the wrong data. You shouldn't be doing it. And we don't like it. So it was I came in thinking I was fancy and left thinking I was not so fancy. And Eric, I don't, so the good thing is that we meet with these folks every week. So every Monday we talk. And so it's just an ongoing conversation. And I realize, and they're not wrong. The data are bad and indicate bad things. And it is information that should be considered for use with careful attention. So yeah, the only way that it seems to work is just to kind of have longer partnerships where trust can evolve.
Yeah, no, that makes a lot of sense. So, I mean, the data is not perceived as trustworthy. Academics are not always perceived as trustworthy. Community and researchers coming together is something that, I mean, at least in my experience, I would echo what you just said, which is that, it's something that takes time and energy and effort and continuous engagement to really be able to hear one another effectively. So we've got two other questions. So the first is the HUD rules at CPD 1701 require communities to attempt to make purely vulnerability-based decisions when prioritizing people for HUD-funded permanent supportive housing programs. So is there some thought at HUD that this should change, or maybe even, since you can't speak for HUD, Patrick, is there some thoughts that you have that this maybe is something that should change? And maybe I'll turn Phoebe to field the next couple questions.
Yeah, I mean, so I don't know what CPD 1701 is. Is that something very specific?
I mean, this is my ignorance as well too. I assume that this is the actual policy that invokes the use of the triaging tools for permanent supportive housing.
Yeah. So yeah, the general, this is the exact issue that motivated this work. Is that, does it make sense to impose a vulnerability-based decision-making, which is one of the two types of local justice allocation schemes? And I don't, well, actually, I don't know if it's right or wrong. It could be the best way to allocate resources. I do think it's probably most beneficial for the community to decide how to allocate the resources. It's just going to be implemented more consistently if everyone has kind of say on how to do things.
Hey, Phoebe, just before you take over, I just want to say, Patrick, thank you so much. I have a qualifying exam for a PhD student that starts in 4 minutes, and I need to host the Zoom room. So I'm going to have to jump from one virtual space to another, but I didn't want to leave without saying thank you so much. It's such a fabulous set of topics, and I'll leave it to Phoebe to finish fielding the last of the questions. Thank you so much.
Thanks, Eric. See ya.
All right, Patrick. So we have a few more questions here. We have one by Earl Edwards, who's asking, I was interested in learning more about the participants of the study's perception of the social problem of homelessness. If someone perceived homelessness as a personal flaw, would that change their outcome orientation?
Yeah, that's we didn't ask, unfortunately. We did collect qualitative feedback on how they were making decisions, and it didn't get at global perceptions of homelessness, but some of the themes that came up were things like, I prioritized if there was a child, or I prioritized just based on efficiency. So we are still digging into this. The one interesting observation so far is that it really was the vulnerability-oriented folks who wrote a lot. Like, they felt like they had to justify themselves, I think. They wrote more words and had just more elaborate explanations than the efficiency-oriented folks. So yeah, that is a really interesting question. And I don't know if we'll be able to get at it directly.
Very interesting. And just as a follow-up, so you explained to them that currently, in principle, is based on vulnerability, the prioritization, because it would feel strange that they want to justify themselves if they know that this is how things are currently done, no?
No, we didn't.
Okay.
We didn't.
Okay.
We left it open to see what they would. We left it purposely ambiguous.
Got it.
So.
That makes sense then. Yeah, interesting. So we have quite a few more questions. Let's take them one by one and see how far down we can get. So Brian Blackwell is saying, thank you for a fascinating presentation. How would you extend this research to a framework where resource allocation decision-making is highly distributed through many complex institutions, where it is unclear how much influence individual agents, e.g. caseworkers, have on the process?
Yeah, so that there's many levels to this. You know, so if we treat it just as like yes, no, who gets in, who gets out, and you know, communities, at least in the homeless world, are increasingly making that like a committee decision, and so that changes the dynamics. That collaborative communal decision making is different than what we are looking at in this framework. We would have to aggregate somehow to you know, the committee or this agency or that agency. So I don't know. I'm not sure how it would translate. It's an interesting, interesting something to think about. It changes that local justice thing. It doesn't fit the definition of local justice. Yeah, and you know, and in these communities, in these aggregates, there's interactions between someone's perceptions of what to do, what's fair, that are continuously being navigated. So yeah, that is an interesting question.
Thanks, Patrick. And we have time for one more question, so let me read it from Andy Perry. I'm just going in order here. Just want to throw out there that bias is a choice of frame that can be counterproductive. If, say, people of color are less likely to have a good outcome as a result of systemic racism, a model that shows that isn't biased. It's accurately measuring racism. The question then becomes not how do we correct for bias in the data, but rather how do we address the racism that we are accurately measuring? Okay, so this was a comment more than a question.
That's awesome. That's a really great comment.
And the question from Graham, how much attention should be placed on advocating more for more resources, e.g. more government funding, versus working to optimize decision-making within a resource-constrained system as it exists today?
Yes. Yes, we should advocate for more resources. And, you know, I truly think it's always going to be an issue. There's never going to be enough resources. So policies that push for efficiency are always going to be present. And so it's yes, and thinking about how these are working.
Right. All right, we're just at the end of the hour. I know there's a few questions left in the chat still. I'd recommend perhaps that people reach out to you, Patrick, if they want them answered. I want to thank everyone for joining us today. And Patrick, thank you so much for a really nice talk. So let's thank our speaker. I'll applaud for everyone. A lot of interest. We had a really huge audience today, so definitely attracted a lot of attention, Patrick.
Well, thank you all. I really, it's fun. It's fun to talk these things out. So thank you for the opportunity.
Thank you so much. And I look forward to meeting you one-on-one on Wednesday then, Patrick.
Oh, cool. Yeah. Okay.
Sounds
all
good.
right.
Thank
you all.
so much.
Have a good day.
Bye.
Thank you. Bye.